Hi, and welcome to another Flipped lesson video. Today's topic is solving exponential equations using the method of common bases. And I'm in the school right now filming this, so there's some background noise. Ignore that for now. Okay, so before we start, we have to recall some facts. Some facts about numbers and what happens to them when we square them and cube them and raise them to other powers. It's going to be helpful if we have certain things memorized already. And so over here I have some basic things that we should automatically know about when we're doing methods of common bases to solve exponential equations. Okay, so the numbers here that you should definitely know and memorize are the numbers for 2, 3, 4, and 5. Memorizing when you square 2, cube it, raise it to the 4th power, and also raise it to the 5th power, all the different values that you get. I don't believe raising 3, 4, and 5 to the 5th is as important as raising 2 to the 5th. So there's certain numbers that you should have committed to memory and know what base goes with each. So let me just explain this. 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, 2 to the 5th is 32. So at any point when I see any one of these bases, I can rewrite 32 as a power of 2. So if I want to have the number 3 and I want to raise this to the 2nd power, it's 9, cubed it's 27, 3 raised to the 4th power is 81. I don't really see too much of raising 3 to the 5th power, so we don't need that as much. Moving to 4, 4 squared is 16, 64, it's 4 cubed, and 4 to the 4th power is 256. Occasionally that does come up. And 5 squared, 25, 5 cubed, 125, and 5 to the 4th power, 625. Now it's really important to be very familiar with these numbers because when you have the SAT, which you'll be taking in the spring, you have a section that you don't get to use your calculators and you need these values. You need them committed to memory. Okay, now, besides knowing that, we also have to recall our facts regarding negative exponents. So recalling that if I have a fraction, 1 over 25, I can rewrite that as 1 over 5 squared, which then I can reciprocate and represent as 5 to the negative 2. 64 can be rewritten as 4 cubed, and if I take 4 cubed, and let me just do this over on the board here, if I take 4 cubed, I can rewrite 4 as a base of 2. So if I have the number 64 and I start with that, and I need to change the base, I would rewrite it as 4 cubed at first. But then, if I need to change it into a base of 2, 2 squared equals 4, and if I raise that to the 3rd power, I use my power to power, very powerful rule, so I'm multiplying the powers. 2 times 3 is 6, so 64 is the same as writing 2 to the 6th power. Okay, all right, now why do we use it? We use all of this because we will want to solve exponential equations in order to find their intersection point. So some problems will ask for a specific point that the two graphs intersect. And that is what's known as solving exponential equations. Because if I have two separate equations and I want to find where they meet, I have to set each equation equal to the other. Okay, so I have an example here of a y equals 2 to the x. And my second function is y equals 8 to the x plus 1 power. Okay, now, we'll find out later on that when you change the x value by adding a constant, it has an effect on the exponential equation similar to every other function. What I like to say is when you mess with x, you're shifting the function left and right along the x-axis. When you add or subtract a constant on the outside of the exponent, as if I was to put it like a plus 3 here, I'm shifting that up if I add and down if I subtract, bringing back that concept of transformation of functions. Now these two functions are both equal to y. So by substitution method, I could set them equal to each other. And if I set them to equal to each other, I could find the x value where they intersect. Now, I can't easily solve this without changing the base, and I want to do this algebraically. So 2 is the smallest base that I can have for the number 2. 8 I can change into the base of 2. So you think, how can I rewrite the number 8 as a base of 2? So recalling our chart, 2 to the third power is 8. Put that in parentheses and put the exponent on the outside. Now, my tip for you is definitely put this in parentheses, because when I use my power to power property, I have to distribute the 3. So 2 to the x equals 2 cubed to the x plus 1. Now what happens is, when these bases match, you're allowed to drop the bases and equate the exponents. And now I can solve a simple equation, x equals 3 times x plus 1. So moving over to the side, x equals 3 times x plus 1 becomes 3x plus 3, subtracting 3x, I get negative 2x equals 3, dividing by negative 2, I get negative 3/2. Okay, so the value that they intersect for the x coordinate is negative 3/2. Then you take that x coordinate and I sub it in to find my y coordinate. Y equals, put it into any one of the other two equations from the beginning, 2 to the negative 3/2 power, and of course I'm going to get a decimal answer here. This is the square root of 2. Well, first of all, let me reciprocate it, because it's 1 over 2 to the positive 3/2 using our exponent properties. And then I take the square root of 2 and then cube it, and that will give me my answer. Okay, so that part you'll do on your calculator. Square root of 2 times square root of 2 is 2. This comes out to be 2 square roots of 2. Since square root of 2 times square root of 2 is 2, the square root of 4, which is 2, and then the 1 square root of 2 is just left over. So we ended up with an answer of 2 square roots of 2. Okay, now other bases that you'll have to change, you may have to reciprocate them first, and you may have to raise them to negative exponents in order to change their base. So let's do one where we have to change two bases at the same time. So let's do, let's see, 16, and I'm going to raise that to the, let's do 1 over 16. Let's do 1 over 16 to the x minus 3, and I'm going to equate that to, let's see, 64 to the 2x power. Okay, to solve this, first of all, I have a fractional base, and I can't have that. So I have to bring it to the numerator. And in bringing it to the numerator, I'm going to raise it to the negative power as such. Equals 64 to the 2x. I have to think, 16 and 64, how can I rewrite each of those bases to match a power? Well, 16 is 4 squared. So I'm going to rewrite that as 4 squared. Raised to the negative x plus 3, distributing that negative in there. And 64 is 4 cubed raised to the 2x. So I'm replacing the 16 with a 4 squared. I'm replacing the 64 with a 4 cubed. Now, the bases are the same. When the bases are the same, we drop the base, and now we equate the exponents, and we use the distributive property to solve for the rest. Okay, so 2 times negative x plus 3 equals 3 times 2x, and we're going to finish up and solve that equation. So 2 to the negative x plus 3 becomes negative 2x plus 6. 3 times 2x becomes 6x. Adding the 2x to the other side, I get 8x equals 6. Dividing both sides by 8 and reducing the fraction because both of them can divide by 2, I get 3/4. So x equals 0.75 or 3/4. After that, you're going to pick one of the two original if you have to solve for y. In this case, I was just looking for the x because I gave you a straight out equation. Okay, so the method of common bases, again, we're taking the base, you're rewriting the base in a common base. So recalling all of the different squares and cubes of our basic numbers, usually 1 through 5 is the ones we want to remember, or 2 through 5. And we want to rewrite each one of them in a smaller base. And then your power is inside and raised to the power of the original equation. Power to power rule, we distribute in order to bring that power together and multiply that together. And then once the bases are the same, we get to cancel them and equate the exponents together to solve for x. Okay, so that's the method of common bases. If you have questions, please jot them down, bring them to class, and don't forget to subscribe, like, and share the video. Thanks, bye.